Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about voltage set at transmission line and its mitigation. First of all, we will introduce ourselves. My name is Muhammad Afiq bin Chairul Ma'arij. My metric number is CE180120.
My name is Muhammad Azizi Aswad bin Hisham. My metric number is DE180187.
Assalamualaikum. My name is Ahmad Daniel bin Muhammad Fauzi. My metric card number is CE180085.
Assalamualaikum. My name is Muhammad Hazib bin Haslin and my metric number is DE180213.
Okay, so we start with introduction. This chapter focus on the definition, measure and classification of electric power quality as well as related issue. Power quality can be defined as the measure, analysis and improvement of the bus voltage to maintain a sinusoidal waveform at rate voltage and frequency. Main cause of disturbance and power quality problem are unpredictable events, the electric utility, the customer and the manufacturer. Voltage sag is by far the most serious power quality issue. It is defined as short duration reduction in voltage magnitude. The principal cause of voltage sag is a short duration increase in current, usually appearing during motor starting, transformer energizing, and fault. The main concern about voltage sag is their effect on sensitive electrical device, such as personal computers, adjustable speed drive, programmable logic controller, and other power electronic equipment. Okay, next, for the literature review, voltage sag represents short voltage reduction of 10% or more below half period of time, ranging from a second cycle or millisecond to centuries of millisecond or short reduction in RMS voltage. This happens when the load rise, such as a short circuit or breakdown, engine start, or electric heater. It can also occur when a loose connection is usually caused by step increase in source impedance. The most common power disruption at industrial plant are the voltage sag. Okay, for the harmonic, you can see the picture next. Harmonic is described by IEE as sinusoidal voltage or current having frequency that are integer, multiple of the fundamental frequency at which the power system is designed to operate. This means that the harmonic frequency for the 60 Hz system are 120 Hz second harmonic, 180 Hz for third harmonic, and so on. Harmonic combined with a fundamental voltage or current that produce a non-sinusoidal shape, thus creating a problem of waveform distortion of power quality. Next, I will pass to Ahmad Daniel.
Okay, so next our methodology. So our function description, Simulink has been used to solve the case. Simulink is a MATLAB-based graphical programming environment for modeling, simulating, and analyzing multi-domain dynamical systems. By simulate the model, the voltage, current, and electric power graph is obtained from the scope. Okay, for the firstly, put three-phase source generator with the parameter of 60 Hz frequency and VRMS is 11 times 10 power of 3 at the start of the circuit to generate the voltage source. Next, a three-phase circuit breaker to protect the circuit from overloads and short circuit. When there is fault detected, it will cut off the electricity supply of the installation and allow its restoration when the anomaly has been solved. Next, the bus is put at the start because we want to reduce the initial number of lines required to route signals from one part of a diagram to another. After that, the three-phase VI measurement is put at the start of the circuit to measure the initial voltage and current. Scope at the start is used to show the initial voltage and current. Then put another circuit breaker in the middle of the protect the generator at the end of the circuit. Next. Okay. After that, put 3RL load and core RLC load. Then put the VI measurement to find the voltage and current. The scope is used to show the voltage and current. There is also bus at the middle of the circuit. Then we put another VI measurement at the end of the circuit to measure the end voltage and current. There is also scope to show the end graph. And finally, there is bus and also the second generator running to separate power circuits to each power supply also allows you to perform maintenance and other work on the electrical equipment without taking the device offline. The setup is especially ideal for when uptime is critical. Next, we're gonna see our project flowchart. Next, next. Azizi minta tolong next Azizi ni. Okay. Okay, our flowchart. So we start from the start, then insert our parameter. Then we have to run our simulation. If there is negative feedback, it will go back into our insert parameter. Then after we have the correct parameter, then we go to the result and data parameters shown by the graph. Then discussing the analysis the graph, then conclude whether it is stability. That's all from me. Next.
Okay, for the result, I'm going to explain the result of our project. Okay, this is for the steady state for generator 1. The voltage ABC at the generator 1 and the current IBC ABC at the generator 1. And this is for the voltage ABC at the generator 2 and the ABC at generator 2. And this was voltage ABC at the load and the current IBC at the load. This is before we put the fault in the circuit. Next, after we've put the fault in the circuit, the voltage at generator 1 will be decreases and the current at the generator 1 will be increases. And for the voltage at the generator 2, it will be the same. It will be decreases and for the current will be increases at generator 2. But the voltage at the load is decreases and the current for the load is also decreases. And after we put the protection relay, the voltage at the generator 1 and the current at the generator 1 will be cut off because the protection relay acts as sensing to detect the fault. Then after its know its location, finally they give the circuit breaker a tripping command. Moreover, when the switching time for the fault was set as 0.2 seconds, the relay send the signal to the circuit breaker if there is an interruption in the circuit. The circuit breaker detach the defective component from the protective relay, and the circuit breaker switch is open. The after relay operation at generator 1 was separated by generator 2 and the load. By rapidly, fault creating the assistance of quick acting protective relay and related the circuit breaker. The damage to the equipment is minimized and the resulting hazard such as fire mitigate the risk of life by removing and especially faulty portion. For the voltage ABC at generator 2, it will be normalized back after there's a fault in the generator, and is the same as current at generator 2. The generator 2 and the load LD run normally where the waveform for the IABC and VABC is in stable equilibrium after 0.2 seconds. Lastly, as a consequence, the transient state stability limit of the system is increased significantly. Long-term destruction to the devices is resisted. The chance of creating the easiest fault, such as single phase to ground fault, into the most severe fault are mitigated, such as with a dual phase to ground fault. That's all for me.
Okay, thank you, Aziz Yaswat. Okay, now I will explain for the discussion part. Okay, the main focus of this paper is to mitigate voltage sag in transmission line. Transmission line can vary in length from several hundred feet to several hundred miles, and in voltage, which is line to line from 46 kilovolt to 750 kilovolt. Example of causes of voltage sag are forest or bushfire, ground encroachment, metal theft at transmission tower, lightning and birds on power lines. Voltage sag gives severe impact to the industrial customers' equipment. The electrical schematic made using MATLAB software shown that how the electricity delivered to consumer from power plant or generator to transmission line and lastly to the consumer. Based on electrical schematic, there are two generator installed. So if generator 1 having failure, generator 2 are ready to supply electrical energy. There are many ways to mitigate voltage sag. For example, UPS, CVT, VDC, DINACOM, and DYSC. Okay, for this paper, we are using UVR, which is under voltage relay. Based on the result obtained after fault applied at generator 1, the scope shows that current start to increase rapidly at time 0.2, while the voltage has dropped to 0 from normal condition. At generator 2, the scope shows the current is increasing and the voltage is decreasing, while at load, the scope shows both current and voltage has decreased. When the protection applied while is protective relay, we can see that the waveform of voltage for 0.2 second, the graph is in equilibrium. The protective relay acts as sensing detect the fault, then knows its location, and finally give the circuit breaker a tripping command. Okay, for our last part is which is conclusion. We have fulfilled the objective for this project, which is to allow the students to be familiar with generation of power quality disturbance and their respective mitigation. Day by day, the increasing demand for electric supply by humankind, it leads to increase the complexity of power system. This will cause the occurrence of a fault in the power system. Most faults have come from the transmission line process because the transmission line is exposed to the surrounding. To mitigate this problem, protective relay has been chosen, which is UVR. And under voltage relay operates when the voltage that flows through a relay's coil fall below a predetermined value. UVR protect loads against voltage drop that can lead to power shortage and brownouts. The relay contact trip to circuit breaker when the voltage decrease to a certain level. For the purpose work in future, develop a method to estimate the location of the fault upstream or downstream of the distribution utility busbar connection to the transmission grid. Okay, that's all from us. Thank you.